Greetings to all of you. In today's session, we are going to discuss about intermediate chemistry, which is helpful for the international floor where you can achieve any entrance examinations or else competitive exams you are preparing for. In addition to this one, JEE Advanced and JEE Mains Chemistry for IITs and NITs engineering stream, need chemistry for the medical entrance examination. Telangana and Andhra Pradesh MSET for engineering entrance examinations. In addition, if you are preparing for any government exam, general studies question paper will be there. In that, the common chemistry questions will be coming from this kind of sessions. Let's enter into our today's session. Name the following compound as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. And as per this IUPAC, we have to assign the name for the compounds whichever provided here. All these are the part of what? Nitro compounds. And you can see one carbon containing nitro, two carbons containing nitro, three carbons and three carbons, but nitro position got changed. Right, this is the way compounds are provided. We need to assign the name as per the IUPAC protocols. Let's see how can we give the names. Right, so being it is the one carbon system, let me mention alkane as a methane, and for nitro alkanes the IUPAC suggested nitro can be combined with alkane. Okay, so here longest chain should be taken as the parent chain. A nitro alkane is the IUPAC nomenclature general description. Right, so here CH3NO2 can be mentioned as one nitromethane. IUPAC nomenclature, one nitromethane will be there. One denotes nitro is located on the first carbon and methane is the of one carbon atom. In the similar manner, second compound is having two carbon chain with NO2, where you have to assign one nitro again, because nitro is located in the first carbon, so that one nitro is the suffix over here. Ethane is the parent chain name, right? And three carbon chain with NO2, let me mention one nitropropane. Okay, three carbon chain, so that propane is the alkane name and nitro is located in the first carbon. One nitropropane is the IUPAC name of the compound. Right, in the similar manner, nitro can be located on the second carbon, so that name will remains, parent chain remains three carbon only, but a nitro position you have to mention it as a 2-nitropropane. This is the way we can assign name as per the IUPAC. And what will be the rules and regulation provided for nitro group by IUPAC nomenclature? Nitro is given by NO2 functional group, and as per the IUPAC it is written like a above rule. NO2 can be written, right? Corresponding alkane can be displayed along with the nitro, so that it can be represented as a nitro alkane. This is the way you have to mention. Here compound one is treated as a what? Nitromethane, and the second will be nitroethane, third one nitropropane, and fourth one will be 2-nitropropane. This is the way we can answer question number 1 as per the IUPAC protocols. Move on to question number 2. In the question number 2, this is question given from Cambridge Assessment International Education. Here sodium hydride was taken. Sodium hydride reaction with the iron oxide. Iron oxide is Fe2O3. Ferric oxide we are taking, and sodium hydride is treated. What they are asking for? Balance the equation for this reaction. Equation to be balanced. In order to balance this equation, what to be taken as the coefficients in front of these products? Okay, that to be determined. And one more question is there. Explain how this equation shows iron plus 3 oxide is reduced. In this, they are saying iron oxide is reduced. Okay, both the question to be answered, right? Let's see first question, balance the equation. Whenever equation was taken, ferric oxide to be converted into iron, if you count iron, how many are there? 2 iron are there. So that in the product also. So this is called law of conservation of mass. This is in accordance with the law of conservation of mass. What is meant by law of conservation of mass? Whenever you are taking reactants and the same extent of products to be generated, matter can't be destroyed nor be generated. Okay, that is the way. So here 2 irons to be relocated in the product as well. So that let me put 2 as the coefficient in front of iron, and count the number of sodium in the reactant. You can find 3 sodium, no? So that product also sodium atoms must be 3. So 3 exponential can be taken. 3 what coefficient can be taken over here. Here 3 oxygens are there. So here 3 oxygens also balanced. If you see, 3 hydrogens are there in the reactant, so that 3 hydrogens, everything got perfectly balanced, so that it is said to be a balanced equation. Fe2O3, 3 sodium hydride gives rise to 2 iron metal and 3 sodium hydroxide. This is the way we can answer this question 1. Move on to question 2. They're asking for, in this equation, iron plus 3 oxide got reduced. How can we say iron plus 3 got reduced? Initially, it is in ferric oxide form, and finally it converted into iron metal. We can explain its reduction by means of 2 ways, in terms of electrons, in terms of oxygen. In 2 ways you can explain, you can define it, it is the reduction process. Let me mention first in terms of oxygen. Here, any compound losing oxygen is said to be reduction. Gaining of oxygen is called oxidation. That is one way of reduction process. In the second, let me explain in terms of electrons as well. Right? Whenever Fe2O3 was taken, ferric oxide when taken, ferric oxide is having iron in plus 3 form. Iron plus 3 oxidation state is possible, and 3 electrons gained by the central iron metal, so that Fe plus 3 got compensated and iron will be turned into a Fe0. Iron metal formation is possible, right? Plus 3 by gaining electrons converted into iron 0. So always gain of electrons is nothing but reduction process. This is the way also you can explain iron plus 3 oxide got reduced. In the both the ways you can say loss of oxygen called reduction, gain of electrons also called as reduction. So this is the way answer to question 2 can be answered. Move on to question number 3. Question number 3 is collected from JEE Advanced 2022 question paper, where you can find a list 1 and a list 2 elements in separate compartments. And this is the part of what coordination chemistry again. Here compounds are complex compounds are provided to you. Sorry, complex ions are provided to you, and certain data is given which is suitable with which kind of list we need to search about that. Okay. Here is the compound chromium hexacyano -4 is given. Ruthenium Cl6 -2 is there. Chromium H2O taken 6 plus 2 is there. Iron H2O taken 6 plus 2 is there. All are said to be what kind of octahedral complexes only. And they provided some hint over here. Chromium atomic number is provided as 24. Ruthenium is given as 44. Iron is given as 26. Match the metal species of list 1 with their properties, list 2, and choose the correct options. Multiple options may correct with one complex as well. You can choose multiple options rather than one option. Okay, this is the way we can answer. Among all the options provided, option A is the exactly correct. Okay, how can we say option A is correct? So 1. Chromium Cn taken 6 -4 if taken, R is the correct. Low spin complex ion. It is of low spin complex ion. And one more is T. So D4 system, D4 species it is. And second complex ruthenium Cl6 -2 if taken. So metal ion of +4 oxidation state. And third option, QT are correct. Chromium H2O taken 6 plus 2 if taken. So Q will be mu spin only will be 4.9 Bohr magnetons. T will be D4 system it is. Okay. If you are going with the fourth one, FeH2O taken 6. Iron hexa aquo complex ion was taken, and the correct options are P. T2G orbital is having 4 electrons, and Q. What mu spin only value will be 4.9. So this will be the right arrangement. We will see how can we justify this answer. Okay. So in order to explain all these properties, all these properties of the complex ions, here first of all we have to go through this spectrochemical series. Spectrochemical series stands for the increasing order of strength of all the ligands. How the ligands are increasing their strength entirely represented in a spectrochemical series. Everything is clearly mentioned over here. Among all, initially the ligands which are laying are said to be high spin complexes. They are able to generate the high spin complexes. The ligands whichever stronger in nature able to give low spin complexes. Weak field ligands are able to give high spin. Strong field ligands are able to give low spin complexes whenever they are binding with the metal, central metal. Okay, so this is about what spectrochemical series, arranging all the ligands according to their strength. Increasing order of their strength is said to be spectrochemical series. Fine. So here, let's see one by one. Chromium Cn taken 6 minus 4. This is said to be hexacyanochromium minus 4 ion, right? So whenever this is the complex, and let me assume this is a chromium and surrounded with the nitriles, 6 nitriles are there, and it is accompanied with the -4 charge. Okay, so here nitrile is said to be what? A strong field ligand, no? So that low spin complex will be generated. So whatever we mentioned exactly correct. So it is of low spin complex, that perfectly correct, because nitrile in the spectrochemical series where it is laying, it is in the low spin complex range because it is a strong field ligand. Strength is very large. Okay, so that's the reason why. So strong field ligand and low spin nitrile will be there. And if you see this chromium, if you see this chromium atomic number 24 they mentioned, and according to that one, it will contains 3d4 and 4s2, but half filled more stable. That's why exceptionally configuration will become 3d5 4s1. Okay, so whenever two electrons are removed from this, if you are removing two electrons from this one, what happens? So the outermost shell two electrons got removed and chromium is converted into a chromium plus 2. So if you see this chromium C and taken 6 minus 4, here chromium is accompanied with the chromium plus 2, no? Because here we have 6 negative charges. 4 negative charges got compensated with these 4. Leftover will be 2 charges only. So that chromium plus 2 will be there. Whenever chromium plus 2 is there, you can remove 2 electrons from the valency shell. Whenever 2 electrons got removed, and the leftover will be D4. D4 it is represented with the 4 electrons in the degenerated d orbitals. This is the way we can explain T, D4 species. It's very clear because chromium is becoming chromium plus 2, so that it is the D4 system. Just now we explained about that one. Here if you see, chromium plus 2 is a D4 system with the 4 electrons in the degenerated d orbitals, right? So this is about what? Chromium. Move on to ruthenium. Ruthenium Cl6 minus 2, what they are saying? In ruthenium Cl6 minus 2, the option is metal ion of +4 oxidation state. Let's see whether it is correct or not. Ruthenium metal Cl6 minus 2 if taken, ruthenium metal is having the outermost shell configuration 5s to 4d6. Whenever 5s to 4d6 is there, what we are doing here, chlorides are 6. That means 6 negative charges are there. To compensate 2 negative charges, here we have a -2 charge over there. Okay, so that here 2 charges got compensated. Leftover will be 4 charges. 4 negative charges are there. 4 negative charges accompanied by the 4 positive charges and the ruthenium. So that ruthenium is becoming ruthenium plus 4. Okay, ruthenium Cl6 minus 2 if present, what we can say, 6 negative charges are there. 2 cancelled with the 2 charges with this, right? Whenever 2 got cancelled, leftover will be 4. So that whatever 4 negative charges are there, so oppositely this central metal will accompany set of 4 positive charge. So that ruthenium plus 4 will be the oxidation state around the central metal, right? So this is perfectly correct. For second question, S will be the correct representation. Move on to chromium complex. Chromium H2O taken 6 plus 2. So let's see what are the correct one about chromium H2O taken 6 plus 2. Whenever chromium H2O taken 6 plus 2 is considered, again here chromium is existing in plus 2. Whenever plus 2 oxidation state is there around the central chromium, it will be D4 system. 4 electrons are laying in the d orbital. Calculate the spin only magnetic moment value. In order to calculate spin only magnetic moment value, we have the formula mu spin only is equal to root of n into n plus 2. And Bm denotes what? Bohr magnetons. Always this magnetic moment is denoted in a Bohr magnetons, and spin only value, the formula will be under root n into n plus 2, right? So here chromium plus 2 complex was taken. So we have 4 electrons. N can be substituted with 4 value, so that root of 4 into 4 plus 2 can be taken. Root of 4 into 4 plus 2 is root of 24. Root of 24, if you go for the logarithm, root value calculation, it will be taken as a 4.89 Bohr magnetons. 4.89 Bohr magnetons. What they are saying, let's see. Okay, for chromium H2O taken 6 plus 2, the correct option will be Q. Q means mu spin only will be 4.9 Bohr magnetons, what we calculated, perfectly matching. And another one is T. What is T? D4 species it is, right? Let's see whether it is D4 or not. If you see this chromium H2O taken 6 plus 2, it is what D4 system only, no? So that D4 system is correct, and spin only magnetic moment value is calculated as 4.89 Bohr magnetons. Both are correct answers only, right? So that QT is the correct answer for chromium hexaquo cation. Move on to FeH2O taken 6 plus 2. FeH2O taken 6 plus 2, what options are correct? Let's see. When hexaquo iron complex was taken, initially let me mention iron electronic configuration. Outer shell configuration is taken as NS2 NP6, NS2 N minus 1 D6. That is given as 4s2 3D6. 4s2 3D6 if present, this iron is becoming iron plus 2. So that Fe plus 2, let me remove 2 electrons from this 4s orbital, and it will become what? 3D6. The orbital configuration will become 3D6. Okay, so it is the 3D6 system. What they are saying about that one? In case of this one, they are saying about P and Q. T2G orbital contains 4 electrons, and Q is also correct. Mu value will be 4.9 Bohr magnetons. These two should be satisfied. Let's see whether it is correct or not. T2G orbital should contain 4 electrons, and magnetic moment must be 4.9 Bohr magnetons. Let's see about that one. We got Fe plus 2 electronic configuration now. Now, in this Fe plus 2 configuration, you can find a 3D6 system. 3D6 means 5 degenerated orbitals singly occupied with 1 electron, and 6th electron will come into this one. So that this is the electronic configuration, right? Whenever sp3d2, it will participate in sp3d2. How it will participate in sp3d2? Outermost shells will be combined with the 6 water molecules like this, being it is the hexaquo complex. You can get 6 electrons from the 6 ligands. 12 electrons from the 6 ligands, all can be accommodated over here. This is about what? sp3d2 hybridized orbitals, right? So what we are seeing about iron plus 2. In the iron plus 2, as you already aware that 6 electrons are there. So in this octahedral complex, always in case of octahedral complex, so 5 degenerated d orbitals will split into T2G orbitals at the bottom, EG orbitals at the top. And let me locate all 6 electrons over here. So 1, 2, 3, 4, 5, 6th electron again comes into T2G. So the P statement states that around this central metal, T2G orbital is occupying 4 electrons. That is perfectly correct. 4 electrons are laying in a T2G orbital, right? This is correct. Move on to another. Again, we have to go for its spin only magnetic moment value calculation. It is given by mu is equal to under root n into n plus 2 Bohr magnetons. So again, we have to put n value. What is n value? Number of unpaired electrons present in Fe plus 2. Total d electrons are 6, but 2 electrons under paired condition. Exclude that. Leftover will be 4 odd electrons are there. N value will become 4 again. So that root of 4 into 4 plus 2 can be taken for the magnetic property determination. It will become root 24. That value will be 4.89 Bohr magnetons. This is the way we can answer the question. And that is mentioned over here. PQ are the correct answer. T2G orbital contains 4 electrons for FeH2O taken 6 plus 2, and mu value will be 4.9 Bohr magnetons. So this is the way for question number 3. Option number A will be the correct answer. Move on to question number 4. Question number 4 again is the kind of match the following question only, where you can find aniline, cresol, cysteine, caprolactam. All these are said to be organic compound. And what kind of determination test? That means their detection. We are identifying these compounds. So those are given in the list number 2. Okay. For aniline, the correct answers are P and S. What P is saying? Sodium fusion extract for the compound boiling with the ferrous sulfate, followed by acidification concentrated sulfuric acid, Prussian blue color is obtained. Aniline will give Prussian blue color with the sodium fusion extract test. Okay, that is correct. And S. So S, what S is saying? The compound react with the bromine water to give white precipitate. Aniline when treated with bromine water, white precipitate will be formed. Let's check whether it is correct or not. Ardocresol. This is another organic compound. Its a correct answer will be T. Treating with the compound neutral ferric chloride produces violet color. Cresol upon treating with the FeCl3. FeCl3 is the identification test for OH, hydroxy functional group. Cresol is of hydroxy compound, no aromatic hydroxy compound, so that it will be reacted with ferric chloride and violet color will be appeared. So this is correct. Cysteine. Cysteine is of amino acid. Cysteine is the amino acid containing sulfur and additional heteroatom. Okay, whenever system is taken into the consideration, Q will be the correct answers. What Q says? Sodium fusion extract of the compound treatment with the sodium nitroprusside. They are treating with sodium nitroprusside reagent. It gives the blood red color. Sodium nitroprusside is selective for the identification of sulfur. So it is giving red color indicates that this cysteine is of sulfur containing compound. Another is about caprolactam. Caprolactam is the cyclic amide. Cyclic lactam is nothing but cyclic amide. Okay, this is the starting material for the synthesis of polylactic acid. Caprolactam is the material. Sodium fusion extract test, it also gives what Prussian blue color because, so this Prussian blue color is the identification of nitrogen present in the compound. Aniline contains NH2, in that nitrogen is there. Caprolactam contains amide, in that NHC double bond O is there. So that common thing is nitrogen. Blue color is due to what? Presence of nitrogen. This is the way we can answer this question. Let's see detailed explanation about that one. P. P for what? P for aniline. If we are taking aniline, in that aniline is a benzene with NH2 functional group on its surrounding. So that sodium fusion extract contains a sodium metal, in that we are only adding that one. And being it is the aromatic compound contains a carbon, and aniline contains NH2, in that nitrogen will be there. Whenever these three together heated, so that we will get sodium nitrile. NaCN is called sodium nitrile. Whatever nitrile released can be treated with Fe plus 2 because here the reagent added will be ferrous sulfate. No, freshly prepared ferrous sulfate can be treated. Okay, whenever ferrous sulfate is reacted, we will get a complex. Iron hexacyano complex will be formed. This iron hexacyano complex can be treated with ferric ions now. So because the ferrous is unstable, readily turned into ferric by air oxidation. So that ferric will be reacted with this ferrous complex. There is a formation of ferrocyanide. The complex formed is called ferrocyanide. Okay, that will contain the color called Prussian blue. Prussian blue is represented in this test tube. The royal blue color will be there. This is given for the identification of nitrogen. Being aniline is of NH2 nitrogen, so that we will get a blue color. Blue coloration is the indication of presence of nitrogen. That's very clear now. Move on to S. S is taken as a aniline. Again, aniline compound was taken. So this is a benzene with NH2. You are treating with bromine water. Whenever bromine water is treated, aniline is of highly reactive, no? So being it is a reactive compound, whatever orthoparasites are there entirely occupied by the bromonium ion. So that tri-substituted compound we will get. So 2 comma 4 comma 6 tribromoaniline we can say. 2 comma 4 comma 6 tribromoaniline. Why we are getting this much of substitution? Because NH2 is of orthopara directing group, and moreover NH2 is more reactive. That's the reason why bromine can be freely occupying all the expected orthopara positions. What are orthopara positions? 2 comma 6 are ortho, 4 is the para, entirely occupied with the bromine, so that tribromoaniline will be generated. Tribromoaniline is of white color precipitate. So for aniline, P is correct answer. S is also correct answer. Move on to orthocresol. What orthocresol is doing? Let's see. Orthocresol, generally, orthocresol is represented with the uh, orthomethyl phenol. This is the compound called orthocresol. Orthocresol, upon treating with ferrichloride, ferrichloride is a selective reagent to identify OH group presence. Presence of OH group can be identified. Simply we mentioned over here. If you are taking only phenol without this CH3, only phenol OH containing compound was taken and treated with ferric chloride, the possible product will be ferric phenoxide. 3 moles of phenoxide combined with iron, ferric phenoxide violet color will be generated. In the similar manner, though here we have methyl that will not react in the reaction, this OH only reactive towards ferric chloride and taken thrice can be bonded to the iron, and this is called ferric cresol oxide, which exists in violet color. So ferric chloride test is specific for the identification of OH group in the given compound. Violet coloration appearance indicates what presence of OH in the given compound. This is the way you can analyze, right? For cresol, the correct option will be T. Treating with the neutral FeCl3 produces violet color. Just we saw violet coloration in the test tube. That's correct. Move on to cysteine. Cysteine is the amino acid. Q, R are correct. Let's see how can we answer this. Okay, cysteine is the amino acid. You can locate a COOH on the first carbon, NH2 on the second carbon, third carbon is accompanied by SH, right? So we are performing sodium nitroprusside test. Whenever sodium nitroprusside is added, sodium nitroprusside stands for Na2FeCN5NO. Whatever the compound we have with the sulfur that can be added over here. NO is converted into NOS. Whenever NOS is formed, that is deep blood red color solution will be generated. This is cysteine upon treating with sodium nitroprusside. Only the change you can notice is NO is turned into NOS because it will abstract the sulfur from that compound. So initially, if the compound is purple color, after treating with this one, it will be turned into a blood red color. That is the identification of sulfur presence in the compound. Okay, that is about Q. What Q says? Sodium fusion extract upon treating with the sodium nitroprusside gives the blood red color. We perfectly got it. And move on to R. Let's see how can we justify that R. So this again cysteine can be taken treated with sodium bicarbonate. NaHCO3 is called sodium bicarbonate, what we are using as a edible soda at home for baking purpose. Okay, so this sodium bicarbonate upon treating with the cysteine, what it will do, it will extract the H plus ion, and there is a formation of sodium salt of cysteine, and whatever carbonic acid generated can release carbon dioxide. So carbon dioxide evolved, bubbles of carbon dioxide evolved because from this we are able to generate sodium salt of cysteine, and whatever H plus added over here can be generating carbonic acid. Carbonic acid subsequently decarboxylated to give carbon dioxide gas. Effervescence will be observed. Okay, so for that purpose, what R is saying, addition of compound with the saturated solution of sodium bicarbonate results in the effervescence. Effervescence are nothing but bubbles. You can see bubbles on the surface of the solution. Those bubbles are because of carbon dioxide gas evolution. Just now we saw the chemical reaction, right? So cysteine is of sulfur containing amino acid that used to give blood coloration with the sodium nitroprusside due to the presence of sulfur, and it will give the effervescence due to the evolution of carbon dioxide. Carbon dioxide evolved, right? And the last is about caprolactam. What caprolactam says? P, it says P. Caprolactam is the monomer for the synthesis of polymer, and it will give the Prussian blue color. We already aware that Prussian blue color is the identification of nitrogen, no? This is called caprolactam. Caprolactam, which contains a nitrogen and carbon as well, so that similar kind of reaction is possible, just like aniline, what we discussed as of now. So that sodium cyanide will be formed. Cyanide ions can be treated with ferrous, so that ferrous cyanide complex will be generated, and further treated with ferric ion, ferriferro complex will be formed. Prussian blue color indicated for this one. Prussian blue color indicates what? Presence of nitrogen in the given compound, so that it is also performed. This is the way we can answer. For aniline, PS are correct. For cresol, T is correct answer. For cysteine, Q are correct answer. Caprolactam, P is the correct answer. So for question number 4, so these many topics we need to know them first. How to arrange all these in a particular order is very important. Then only we can answer in a successful way. Anyway, match the following is having some kind of flexibility in order to answer. Though we know only 2 options, it is obvious to get the answer, because the remaining all we can exclude. Somewhere you can find the change in that answer, so that match the following is somewhat convenient to answer. More probability to get the accurate answer for this, right? So for question number 4, option number D will be the correct answer. Move on to question number 5. Question number 5 is collected from Gurukulam Degree College lecturer entrance examination. When cadmium plus 2 ion reacted with ammonia and forms a complex cobalt NH3 taken for plus 2, in the stepwise formation constants determined as K1, K2, K3, K4. What is the correct order? Okay, so here it is the part of coordination chemistry, which is related with its kinetics. So we are applying chemical kinetics to the coordination complexes. This is the kind of question from where it is coming. Okay, so here cadmium complex was taken, and it is of 4 coordination number. And in order to get these many ligands around the central metal, set of ligands are 4, and the central metal is cadmium, so that individual rate constants are mentioned as K1, K2, K3, K4. What will be the correct order? The correct order will be K1 will be higher compared to K2, compared to K3, compared to K4. Okay, let's see how can we explain this one. First of all, we have to get how to achieve this kind of compound in the stepwise manner. They are saying in the stepwise formation, right? Okay, so here initially cadmium plus 2 was taken, aquated solution, and aqueous ammonia was added to that one, so that monoamine will be formed. Only one ligand is around the cadmium metal, so that this rate of the reaction is indicated with K1. Only one step reaction, 1 mole of ammonia is added under aqueous conditions. Whatever complex formed repeatedly treated with 1 more mole of ammonia, so the diamine complex will be formed. Its formation can be designated as K2, and can be continued until cadmium ammonia complex is reaching its maximum limit. That is cadmium tetraamine complex cation will be formed, so that K1, K2, K3, K4 are the individual rate constant for the individual steps. Simply what we are doing, so initially cadmium, cadmium monoamine, cadmium diamine, cadmium triamine, so that we are going to treat in a 1 mole of ammonia, and we are getting K1, K2, K3, K4 as the rate constants. The question is, why K1 is higher? Why K1 is higher compared to K2 and compared to K3 compared to K4? That is explained by this one. Initially, rate of the reaction will be higher and decrease with the time. This is the fundamental concept we have to understand, because initially more reactants will be there. They will move very fastly. They will react very fastly, so that rate of the reaction will be higher. As time passes, reactant concentration decreases, so that subsequently rate of the reaction also decreases. This is the way we can explain. K1 will be higher because initially rate of the reaction is extremely large. As we are moving, K2 will be somewhat slower, K3 will be still slower, K4 will be still slower, because whenever you are starting running, we are having high energy, no? So that our running rate will be very fast. As we are passing after 10 minutes, our energy level somewhat decreased, so that our speed will be somewhat lowered. And still we are moving further. What happens? Our speed is still reduced. At last, it will be somewhat slow. This is the way we can explain how the rate of reaction is descending. K1 will be higher compared to K2, compared to K3, compared to K4. Okay, so this clearly explained by taking time versus concentration. So whatever the reactant taken, as time passes slowly, its concentration is decreasing, and subsequently product concentration is increasing. So because reactants are consumed, products are generated. That's the reason why reactant concentration gradually decreases, product concentration gradually increases, and this will be the right order. K1 is higher compared to K2, compared to K3, compared to K4. For question number 5, option number 1 will be the correct answer. Move on to question number 6. Question number 6 is the last question of the session. Which of the following complex is labile in nature? Labile in the sense which is highly flexible to react further. Whenever it is treated with any other reagent, it readily reacted and new product formation is possible. That is called what? Labile complex. Somewhat flexible, right? So among all, iron hexa aqua plus 2 is a more labile in nature. More labile complex is this one. Let's see how can we explain this, right? In order to explain that one, we have iron hexa aqua complex. It is iron plus 2, right? So whenever iron plus 2, it is of d6. So that let me mention d6 electrons over here, 5 orbitals occupied by 5 electrons. 6th electron enters into this d1. So this is the way d6, 3d6 electronic configuration of Fe plus 2 is there. When hexa aqua is there, hexa aqua means what? S orbital, p orbital, 2 d orbitals got mixed up, and this is of sp3d2 hybridization, and each water molecule is contributing 2 electrons, so that 6 water, 12 electrons you can observe. 2 plus 2, 4, 6, 8, 10, 12. 12 electrons contributed by 6 water molecule ligands, right? So this is about what distribution of electrons in the hexa aqua complex of iron. Let's see how can we say it is the labile complex. In order to explain, this is the topic collected from the Liber text, where octahedral complex which are labile, which are inert, that data is provided by them. Among all, I'm selective for this Fe plus 2 high spin. Why I am saying high spin? Why I am saying high spin means water is of weak field ligand. Whenever weak field ligand is there, the complex is said to be high spin. Strong field ligand like cyanide, nitrile is there, that is what a low spin complex. But water is the weak field ligand, so that we can say it is the low spin complex. Okay. So iron of high spin, because it is the weak field ligand is high spin complex. Iron plus 2 high spin is said to be what? Labile. So for D option, if you see D option, answer D is a labile. Electrons are higher energy d orbital set. Okay, it is of labile complex. Okay, so let's see the entire table. So this is the data collected from Dalal Institute, where D0 system is there, that is labile only. D1 is highly labile. D2 is also said to be labile. D3 is of inert in nature. This is the way we can move on. D6 high spin. This is only required for us. D6 high spin is called labile. This is also saying the compound is labile is nothing but highly flexible, can be treated with any reagent and reactive in nature, right? And the entire table we can go with high spin, low spin purely depends upon the strength of the ligand. Okay, so this is the way we can categorize all the compounds into labile and inert based on the d orbital system, which system it is. So based on that, labile or inert nature will depends. Okay, so that's all for the day. For question number 6, option number 1 will be the correct answer. Labile complex will be hexa aqua iron plus 2 complex cation, right? So hope this entire session is very clear and a detailed explanation is provided to you. And I'm sincerely requesting to like the channel and comment which part is really interesting for you and where you got the real information, and share with the aspirants who are seriously preparing for the examination, and subscribe the channel in order to receive more such kind of updates in the near future. Thank you very much for all of you for giving me the strength to make such kind of videos, and thank you for your patient listening.